Hi everyone, I'm Tejaswini. I'm going to discuss about what are the best practices in software engineering. And this is introduction and overview of 50 best software practices. The other, this is the table of the contents. We are going to introduction to best practices, concept of best practice, multiple paths for software development, deployment, and maintenance. And we're also going to see about what are the overview of all the 50 software best practices that exist. And introduction and definition of software best practices. Here we're going to the introduction. We have going to the past. In history, we have the worst recession at 21st century abruptly started on 5th September 15, 2008, and many companies lost. And critical topics during the major recession are minimizing harm from layoff and downsizing, optimizing software quality control, optimizing software security control, and so on. And if we see that what are the five common problems occurred with cancel or disastrous projects are estimating prior to starting the project were inaccurate and excessively optimistic, and quality control during the project was inadequate, and tracking of the progress during the development was severely inadequate or even misleading. So the change control is also the inadequate, and this is a software engineering development problems, inaccurate understandings of end user needs, inability to deal with the changing requirements, modules that don't fit together, and these are the all software engineering development problems. And first of all, why we need practice? We need practice that will serve as a framework for large scale and small scale projects, adaptive like embrace change, and opportunity of for improvement, not identification of the failure, and it is iterative, risk driven, and architecture centric, and heavy user involvement in that. So, identify best ways of doing things, a better process acknowledged by the world leaders. And this is the drawbacks in traditional methods without practice. Like if we take waterfall model, we have just a sequence like requirements, design, code, integration, and test. There is no iterative process in the traditional waterfall process. So the problem with it is it is inadequately addressed, process not receptive to change, problems not really seen, and big bang approach, long development cycles, and little user involvement in that. And coming to the best practices, these are the best practices of software engineering, which are develop iteratively, manage requirements, use component architecture, model visually, verify quality, and change control. These are the basic components in the best practices. Coming to the first one, develop iteratively. In this, the critical tasks are resolved before making large investment. Initial iterations enable early user feedback, and also testing and integration are continuous in this develop iteratively. And objective milestones provide short-term focus. If we see here, like we have different iterations, iteration 1, 2, 3. We are going to every phase, and will if there is any fault in such a system, we'll go through back and we'll develop the system iteratively. And these are the symptoms, root causes, and best practices. If we take the late discovery, we have root causes like poor testing, waterfall development. And for poor testing, we need to verify the quality, and waterfall development, we need to develop iteratively. And the second one is manage requirements. Managing requirements is very important in order to, before starting the project. So requirements are dynamic, expect them to change during the software development. Users' own understanding of the requirements evolves over the time. Creating the requirements baseline. If you see this diagram, manage versions of requirement documents and adopt enforced change process control, perform requirement change impact analysis attributes, and we need to have check the status of each requirement. We need to have trace the requirement and store requirements in a requirements management tool. And third one is use component-based architecture. If we use the component-based architecture means we'll have to have a different layers like application-specific layer, business-specific layer, middleware layer, and the software layer. And this is a system that is having the different components. And visually model software. So visually model software is very important because if we want to understand a particular thing, the diagrams are very much important. So in software engineering, if we want to understand the business criteria or the project, how to explore that project, we need to have the models like the different models which we have in the software engineering are use case diagrams, class diagrams, object diagrams, deployment diagrams, activity diagrams, and state transition diagrams. And this is an example of the IBM company that they have the sprint, and the previous sprint they have the sprint planning. They exposed this to be as a particular diagram in order everyone should in order to understand by the every user. And the fifth one is verify software quality. First, we need to know what is quality. The characteristic of producing a product which meets or exceeds agreed upon requirements by some agreed upon objective measures. And if we take a particular project, we have different iterations. For every iteration, we need to check the test cases. We need to have different test cases for every iteration, like unit testing, iterative testing, and we also have to make a note that software problems are 100 to 10,000 times more costlier to find and repair after deployment. We need to make note of this and develop test suites for each iteration and test for functionality, reliability, and performance. The last one is change control changes to software, and without explicit control panel development regrets to chaos and decompose the architecture into subsystem. We need to decompose every architecture of the initial stage of the project into subsystem and assign the responsibility of the each system. And we need to have the further we can decompose that subsystem into a number of subsystems so that every subsystem can be act as a work unit. If we see in this diagram, we have the software changes, software enhancements, software problems. All these are commonly fed through the analyze and access impairment. Then we need to have a prepare change protocol, and we need to have some control board, and we also have some and finally we have to verify every test cases, and finally we need to supply feedback to originator. If it is good, then it is we end the process, or else we'll need to go back to the process. And so overview of best practices are develop iteratively, manage requirements, use component architecture, model visually, continuous, verify quality, manage changes. And these are the functions of each of those. And this is the best practices for 1,000 to 10,000 function point software projects. And these are the different agile development high level languages. And projects, at least for those developed by Fortune 500 governance, is in the number 2 spot for the best practices. And coming to overview of the 50 software best practices, we have like in software engineering we have 50 software best practices. These best practices discussions focus on projects in the 10,000 function point range only, and the set of best practices discussed here the entire life cycle from the day a project starts until the day that the application is withdrawn from the service. And these are the 50 best practices like minimizing harm from layoffs and downsizing, motivation and morale of technical staff, motivation and morale of managers and executors, outsourcing, contractors, and software architecture and design, software project planning, risk analysis, value analysis, and software project organization structures, and software project governance, programming and coding, certifications, and software reusabilities. All these are the 50 software best practices. Coming to the first one, best practice for minimizing harm from layoffs and downsizing. First we need to know what is downsizing and layoff. Downsizing is a broad term that refers to reductions in a firm's use of financial, physical, human, or information assets. And the layoff is the suspension or termination of a employment with or without notice by the employer or the manager. And how to minimize harm from layoffs and downsizing. First, analyze and prioritize the applications that are under development, analyze the maintenance of existing legacy applications, and we need to calculate the staffing patterns, and we need to have if we need to have a different managers for different set of teams. And if there is no perfect solution for downsizing and layoff personnel, but cutting specialists and administrative personnel in large numbers may cause unexpected problems in any organization. And suppose if we take an example, like in 2008, for example, IBM spent $700 million in employee restructuring actions at Hewlett Packard. The CEO took a 20% cut, while the other employees forfeited between 2.5 and 50% of their pay. And this is all about, if we see an example like the Zomato layoffs 540 employees from its customer support team, and Uber layoffs hundreds more workers as struggle to make money. This is about the we need to control the harms from the layoffs and downsizing. And this is also an example that Kruger to lay off two store employees, and there's many layoffs going on. We need to know how to minimize those harms from the layoffs and downsizing. And the other one is a best practice for motivation and morale of technical staff. Motivation is a very important for every staff because actually the studies of exit interviews of software engineers at major corporations indicate two distress problems, which are the best personnel leave in the largest numbers, and the most common reason stated for the voluntary attribution is I don't like working for bad management. So our management should be very good. And these are the few some topics noted in a number of leading companies where morale is fairly high, such as IBM, Microsoft, Google, and like. First, we need to see about this. Emphasize doing things right rather than just working long hours to make artificial and probably impossible schedules. These are the different topics that we need to go through it, and what employees really want. If you see that connection, purpose, progress, and feedback, and we need to ask yourself like, what motivates you, what engages you, what could your boss do different to engage and motivate you. These all we need to know. And the other one is best practice for motivation morally. This is the same. And what are the benefits of the highly motivated staff means have fewer absence from work, deliver higher levels of performance, work harder when workplace demands are high, be loyal to their organization, and deliver high levels of customer service. And we have a Google says that Google's focus on happy, committed employees. They have them some functions like message therapy, massage therapy, laundry service, and government meals and snacks they'll purchase to their staff members. Hmm. This is an example template Intel ways to motivate and reward your employees. And the other one is the best practice for selection and hiring of software personnel. In the hiring process, first we need to establish recruitment objectives, then develop a recruitment strategy and carry out recruitment activities and evaluate recruitment results. And the fifth one is the best practice for appraisals and career planning for software personnel. Identifying the specific performance appraisal goals, then we need to establish the performance criteria and communicate them to the employee and examining the work performing and appraise the performance. And these are the steps we need to go in the performance appraisal process. And this is an example that rating skills method performance appraisal sheet format in TRS Texas that I got from my friend who is working there. And the sixth one is best practices for early sizing and scope control of software applications. And since many applications are quite smaller to existing applications, acquiring size data from ISBSG is becoming a standard early phase activity. This data also includes schedule and cost information, so it is even more valuable than the size alone. For example, if you take new method, a new method based on pattern matching can provide fairly good approximations of size in terms of function points, source code, not more than even of other items such as pages of specifications. So early sizing and scope control of a software application is a very much important in every aspect. The other one is the best practices for outsourcing of software applications. Outsourcing plays a major role nowadays in industries. The need of the best practice in outsource agreement is demonstrated by the fact that within about 2 years, perhaps 25% of our outsourcing agreements will have developed some friction between the clients and the outsource vendors. And if you take some big companies like AT&T, IBM, each own well over 10 million function points, and this is a software as a key component under the following conditions like yourself rights that depend upon your own property. And these are the topics that we need to include in outsourcing agreements like the sizes of software contract deliverables must be determined during the negotiations, preferably using the function points. Cost and schedule estimation for applications must be formal and complete, and the creeper using requirements must be dealt with the contract in a way that's satisfactory to both parties, and effective software quality control steps must be utilized by the vendor. And and coming to the advantage of these are the basic examples of outsourcing. Like if you take that US companies charge 80 to 120 per hour for programmers, offshore providers charge about $40 per hour. And advantages of the outsourcing is outsourcing lets you to focus on core activities. It can save cost, promote efficiency, it can keep operational control, it offers staffing flexibility, it provides the continuity risk and risk management. And this is the best practice for user contractors and management consultants. Using the contractors and management consultants, it somewhat reduces our time, and we can do our work very easily within short span of the time. And this is the best practice for selecting software methods, tools, and practices. Selecting a particular software methods is very much important in order to achieve the high success in a project. Some of the methods are software development methods or agile development, clean room method, and hybrid development, iterative development, and PSP, RAD, RUP, and team software process like TSP. These are very much important for the software development. And other one is and what are the points we need to observe is suitability by application of the size, suitability by application of type, and nature and attribute. And these are the acquisition and modification commercial software packages would resemble our requirement analysis, gathering, and inspections, and so on. And the other one is the best practice for certifying methods, tools, and practices. Certification is very important for a person in order to have their in order to know what the person is. So we have the four layer taxonomy: nature, scope, class, and type. And the other one is a best practice for requirements of software applications. Like if we take that new requirements, but should also include data mining of legacy of the course, and gathering analysis of the requirements includes utilization of the joint application design and QFT, and utilization of the security experts, and so on. If you take, we have the requirements modeling, state analysis, test verification. If the